Before we dive in, a quick but important note. This video is for informational and educational purposes only. I am not a financial advisor or a career counselor. The decision of whether or not to pursue a college degree is a massive one with significant financial and personal implications. This presentation is a deep dive into my research, analysis, and the experiences of dozens of professionals, but you should always conduct your own thorough research and consider consulting with a qualified professional to make the best decision for your unique circumstances. Alright, let's get into it. Meet two people. Let's call them Alex and Ben. Alex spent the last 4 years grinding. We're talking late-night coding sessions fueled by cheap pizza, mind-numbing lectures on computational theory, and a final price tag of over $120,000 in student debt. He has a crisp, framed computer science degree from a respectable state university. Ben, on the other hand, spent the last 12 months in his parents' basement. He worked a part-time job to pay for a 6-month coding bootcamp, spent every other waking hour on YouTube tutorials and building projects for his GitHub portfolio. His total investment? Around $15,000. Now, a year after graduation, Alex is on his 300th job application, stuck in a loop of automated rejections for junior developer roles. Ben. He just accepted a 6-figure remote software engineering job at a fast-growing startup. What on earth is going on here? This scenario isn't a fluke. It's playing out in cities all across America, and it raises the single most terrifying and important question for anyone looking at a future in technology. Is the computer science degree, the gold standard for generations, now the most expensive and inefficient way to get a job in tech? Is it becoming obsolete? For the next hour, we are going on a deep dive to answer that question. This isn't another surface-level college is a scam rant, and it's not a defense of the ivory tower. This is the definitive 2024 guide for American students, parents, and career changers. We're going to dissect the data, we're going to hear from actual hiring managers at major tech companies, and by the end of this video, you will have a crystal clear framework to decide if a computing degree is the right path for you, a decision that could save you over $100,000 in 4 years of your life. The ground beneath our feet is shifting. For decades, the path was clear, carved in stone. You get good grades in high school, you get into the best university you major in computer science, and you walk out into a guaranteed 6-figure job at a company like Microsoft, Google, or IBM. The degree was the key. It was the non-negotiable ticket to the game. It signaled to employers that you were disciplined, that you understood the deep theoretical foundations of computing, and that you were a safe bet. Universities were the gatekeepers of knowledge and opportunity. But the world changed. The internet didn't just disrupt industries, it disrupted education itself. Suddenly, the world's best lectures from MIT and Stanford were available for free on YouTube. Platforms like Coursera, Udemy, and Codecademy offered structured learning for the price of a few pizzas. And then came the disruptors in chief, the coding bootcamps. They made a bold, almost unbelievable promise. Give us 6 months of your life and $10,000 to $20,000, and we will turn you into a job-ready software developer. They ditched the theory, the history, the general education requirements. They focused exclusively on the practical, in-demand skills that companies were hiring for right now. JavaScript frameworks, cloud computing, database management. They taught you how to build, not just how to think. In a booming tech market, it worked. It worked shockingly well. Companies were so desperate for talent they couldn't hire fast enough. They started to realize that a candidate with a killer portfolio of real-world projects was often more valuable on day one than a fresh grad who could explain a binary search tree on a whiteboard, but had never worked with a modern API. Google, Apple, and dozens of other tech giants officially dropped the degree requirement from many of their job postings. It felt like the walls of the castle were crumbling. The American dream was being rewritten. You didn't need a mountain of debt to get a top-tier job. You just needed a laptop, an internet connection, and relentless grit. But here's where it gets complicated, and it's why so many people get this wrong. The story of Alex and Ben is real, but it's not the only story. The surprising truth is that the debate isn't about college versus bootcamp. That's a false choice. The real issue is that the university degree and the bootcamp certificate are two fundamentally different tools designed for two very different jobs, and they build two very different types of thinkers. A university is trying to build an engineer. A bootcamp is trying to build a technician. A university is teaching you the physics of how an engine works. A bootcamp is teaching you how to be a great mechanic. Both are incredibly valuable. But if you try to use a mechanic's wrench to design a new Formula One engine, you're going to fail. And if you show up to fix a flat tire with a set of theoretical blueprints, you're going to be useless. The catastrophic mistake people are making on both sides is choosing a path without first understanding the destination. They hear six-figure tech job, and they just start running, grabbing the tool that seems fastest, cheapest, or most familiar. But tech job isn't one thing. Is your goal to be a front-end web developer at a small marketing agency? Or is it to work on the core machine learning algorithms that power Google's search results? Do you want to build and maintain websites? Or do you want to design the next generation of cloud infrastructure for Amazon Web Services? The path to these roles is radically different. One might be perfectly served by a bootcamp. The other might be virtually impossible without the deep theoretical foundation that only a 4-year degree can provide. And the landscape just got a whole lot more treacherous. The tech gold rush of the last decade is over. We've seen massive layoffs across the industry. The era of easy money and hiring anyone who could spell HTML is gone. Companies are tightening their belts. They're becoming more selective. The bar for entry-level talent is rising fast. This new reality changes the calculation for everyone. It means the promises of some bootcamps are starting to ring hollow, but it also means the cost of a 4-year degree is under more scrutiny than ever before. This is a bet on your future, and the stakes have never been higher. Getting this wrong means a decade of digging out of debt, while struggling to find a foothold in a hyper-competitive industry. Getting it right means a launchpad into a career with incredible freedom, intellectual challenge, and financial security. So, to figure this out, we have to go layer by layer. We need to build a mental model for making this decision intelligently. First, we're going to dive deep into the seismic shift that is breaking the old rules of tech hiring. What exactly changed in the last 5 years, and how does the rise of AI and automation factor in? Then we'll pull back the curtain and reveal what hiring managers and recruiters actually care about in 2024. Forget the generic job descriptions. What are the unspoken signals they look for on a resume that make them say, "Yes, I need to talk to this person"? We will get into the cold, hard numbers, the real return on investment. We'll compare the lifetime earnings potential, the debt burden, and the career ceilings for degree holders versus bootcamp grads and the self-taught. And finally, we will build a personalized decision matrix, a set of specific, tough questions you can ask yourself about your goals, your finances, and your learning style to determine with a high degree of confidence which path is truly your path. This isn't about finding a universal answer. It's about finding your answer. So let's start with the 80,000-pound gorilla in the room: money. Not just the tuition fees, but the entire economic equation of your life for the next 4 years, and potentially the next 40. To make this real, let's leave the abstract and talk about someone I know. We'll call him David. David was a sharp kid in high school. Top 10% of his class, captain of the robotics team, scored a 1450 on his SATs. He had 2 letters sitting on his desk. One was a crisp, embossed acceptance to a well-respected state university's computer science program. The other was an email confirming his spot in a top-tier 16-week coding bootcamp. The university letter represented the dream, the classic American path. Football games, a sprawling campus, a degree that his parents could frame on the wall. The total sticker price, after factoring in tuition, room, board, books, and fees for 4 years, was projected to be just shy of $180,000. After some modest scholarships, he was looking at taking on about $120,000 in student loan debt. The bootcamp email represented the hustle, a fast track into the industry, 16 weeks of intense 12-hour days living and breathing code, with a promise of job placement assistance and a direct line to a 6-figure salary. The cost? A flat $15,000. On the surface, the math seems insultingly simple. $120,000 in debt versus $15,000. It looks like a no-brainer. But this is the first and most common trap people fall into. They only look at the sticker price. They fail to calculate the true cost. Let's start with the university. That $180,000 figure is just the beginning. The biggest, most devastatingly expensive part of a 4-year degree is something that never shows up on a bill. It's called opportunity cost. For 4 years while David is in college, he is for the most part not earning a professional salary. Let's be conservative and say that if he'd gone another route, he could have been earning an average of $60,000 a year as a junior developer. Over 4 years, that's $240,000 in lost income. So, the true cost of David's degree isn't $180,000. It's $180,000 in direct costs plus $240,000 in lost earnings. We're now talking about a $420,000 decision. Suddenly, that embossed letter feels a lot heavier. Now let's look at the bootcamp. $15,000. The opportunity cost is much lower. Let's say it takes him a month to prep, 4 months for the bootcamp, and 2 months to find a job. That's about 7 months of not earning. The lost income is maybe $35,000. So the total cost of the bootcamp path is $15,000 plus $35,000, $50,000. So the real comparison is $420,000 versus $50,000. And at this point, you're probably thinking, this is insane. The case is closed. The degree is a financial catastrophe. And if your timeline is only the first 2 years out of school, you might be right. But we're not thinking about 2 years. We're thinking about a career. We're thinking long-term. And this is where the surprising truth begins to emerge. The value of a computer science degree isn't just in the piece of paper. It's in the doors that piece of paper opens, and the foundation it builds. Let's talk starting salaries. Study after study shows that, on average, computer science graduates from reputable universities command higher starting salaries than bootcamp graduates. It's not a huge gap, but it's real. Let's say our university grad David starts at $85,000, while our bootcamp grad David starts at $70,000. That $15,000 difference, compounded year after year with raises, starts to eat away at the bootcamp's initial financial advantage. But the salary is only part of it. The real differentiator is access. Large, established tech giants, the Googles, the Microsofts, the Apples, and high-frequency trading firms on Wall Street, the places with legendary pay and benefits, have recruitment pipelines that are deeply, and often exclusively, embedded in university computer science programs. They sponsor career fairs. They have relationships with professors. They have internship programs that are almost exclusively for current university students. That internship is often a direct feeder to a full-time offer with a six-figure salary and a $20,000 signing bonus before you've even graduated. For many of these elite opportunities, if you don't have a BS in computer science on your resume, your application is filtered out by an algorithm before a human ever sees it. The bootcamp path can get you a great job at a startup or a mid-sized company. It absolutely can. But it's a much harder fight to get your foot in the door at the highest echelons of the industry right at the start. Then there's the knowledge itself. A bootcamp is, by design, vocational. It teaches you the specific tools and frameworks you need to be a productive web developer or data analyst right now. It's like learning how to be an expert mechanic for a 2024 Honda Civic. You'll be fantastic at that job. A computer science degree, on the other hand, isn't about the 2024 Honda Civic. It's about teaching you the fundamental principles of mechanical engineering, physics, and materials science. It teaches you how the internal combustion engine works from first principles. So when the 2034 hydrogen-powered hovercar comes out, you're not starting from scratch. You have the foundational theory, the data structures, the algorithms, the operating systems theory, the computational complexity, to understand and adapt to any new technology. This theoretical underpinning has a long-term financial payoff. It's what allows a developer to move from simply building websites to designing complex, scalable systems, to leading engineering teams, to becoming a chief technology officer. The career ceiling is arguably higher. Over a 40-year career, that initial salary gap can widen into a chasm of millions of dollars in lifetime earnings. The university path is a front-loaded investment for a back-loaded career. The bootcamp is the opposite. So what does this mean for you? It means the financial question isn't, is college worth the money? The question is, what is my personal financial situation and my appetite for risk? If you're 18, have family support, and can access federal loans with reasonable interest rates, taking on $80,000 to $100,000 of debt for a $400,000 investment that could pay off over decades might be the most rational economic decision you ever make. It's a calculated risk with a potentially massive upside. But if you're 28 with a family to support, a mortgage, and no financial safety net, taking on that same debt would be an act of breathtaking irresponsibility. For you, the bootcamp's $50,000 all-in cost and 7-month timeline to a new, higher salary isn't just the better option. It's the only option. It's a lifeline. This isn't about one path being universally better. It's about aligning the financial model of your education with the reality of your life. It's about understanding that the degree is a high-cost, high-risk, potentially high-reward long-term investment, while the bootcamp is a low-cost, low-risk, fast-payout trade. One is buying the stock, the other is buying the option. Both can be winning strategies, but they serve entirely different investors. You have to honestly assess your financial runway. How long can you afford to not work? You have to assess your debt tolerance. How much are you personally willing to borrow against your future self? And you have to assess your career goals. Are you trying to land a job at a Fortune 500 company straight out of the gate? Or are you happy to work your way up through the startup world? Answering the money question requires a level of introspection that goes far beyond a simple tuition calculator. But money is only one part of the equation. Because even if you have a blank check, you might be choosing a path that's fundamentally incompatible with how your brain is wired to learn and what you truly want out of a career. And that leads us to the second critical question you must ask yourself, a question that has nothing to do with your bank account and everything to do with your ambition. What kind of problem solver do you want to be? See, this is where the entire debate goes off the rails. We're so obsessed with the piece of paper, the diploma, that we forget to talk about the type of thinking it's designed to create. A 4-year computer science degree and a 12-week coding bootcamp are not just different in length and cost. They are fundamentally different in their entire philosophy of problem solving. They are forging two different kinds of intellectual weapons. Let's call them the architect and the builder. The architect is obsessed with the why. They don't just want to know that a sorting algorithm works. They want to know why it's the most efficient for a specific type of data. They want to understand the mathematical proofs behind its performance. They lie awake at night thinking about time complexity, memory allocation, and the intricate dance between hardware and software. A traditional CS degree is architect training. It's a deep, often grueling, dive into the theoretical bedrock of computation. You're not just learning to code in Java, you're learning how the Java virtual machine actually works. You're not just using a database, you're designing the logic for a database from scratch. You're studying operating systems, compiler design, discrete mathematics, and data structures. Most of this stuff, a recent graduate will tell you, feels useless on day one of their first job. And they're not entirely wrong. You probably won't be asked to write a compiler for a new programming language in your first gig as a junior web developer. But that's missing the point. The point of this training isn't to prepare you for day one. It's to prepare you for day 1000. It's to give you a set of first principles so that when you encounter a problem no one has ever seen before, a problem that has no answer on Stack Overflow, you have the tools to reason your way to a solution from the ground up. Think of it like this. The architect is a structural engineer. They spent years learning physics, material science, and advanced calculus. They understand the fundamental forces of tension and compression. You don't ask a structural engineer to hang drywall or install kitchen cabinets. You ask them to design a skyscraper that can withstand an earthquake. Their knowledge is abstract, foundational, and aimed at solving massive, high-consequence problems. The Googles, the Amazons, the Microsofts of the world, the companies working on problems of unprecedented scale, like indexing the entire internet or building a global cloud infrastructure, they need architects. They need people who can optimize a system at a fundamental level, where a 1% improvement in efficiency can save $100 million a year. For these roles, the CS degree isn't just a signal. It's the prerequisite training for the job itself. Then you have the builder. The builder is obsessed with the how. They are relentlessly pragmatic. They want to get from an idea to a functioning product as quickly and efficiently as possible. They want to build the app, launch the website, and solve the user's problem today. A coding bootcamp is pure builder training. It is an intense, focused sprint designed to teach you the most in-demand tools for a specific job right now. You'll learn React for front-end development, Node.js for the back-end, how to deploy on AWS, and how to work in an agile team. It's all practical, all hands-on. The goal is to make you productive on a development team on day one. The builder is the master craftsman. To use our construction analogy, they are the elite general contractor. They can take a blueprint and turn it into a beautiful, functional house faster than anyone else. They know the best tools, the best materials, and the best techniques to get the job done. They can frame the walls, run the electrical, install the plumbing, and finish the interiors. The modern digital economy is overwhelmingly powered by builders. Every startup, every small business, every digital agency needs people who can take a business requirement and turn it into a working piece of software. They are the lifeblood of the industry. They take the powerful abstract technologies created by the architects, like cloud platforms and programming languages, and use them to build things that solve real-world, immediate problems for people and companies. Now, here is the great toxic lie of the internet tech sphere, that you have to choose one. That one is better than the other. You see it constantly. The bootcamp grad who says, "I've been a developer for 5 years and I've never once needed to balance a binary tree. CS degrees are a scam." And you see the CS grad who says, boot campers just know how to copy and paste from tutorials. They don't understand how anything actually works. They are both profoundly wrong. They're like the structural engineer and the master carpenter arguing about whose job is more important. It's a pointless debate. You need both to build a city. The truth is, the most successful, most impactful, most highly paid people in this industry are a hybrid of both. They are architects who have learned to build, or builders who have dedicated themselves to learning architecture. The architect who never learns the practical skills of building remains a theorist, unable to bring their ideas to life. And the builder who never learns the underlying principles of architecture will eventually hit a ceiling. They'll face a problem of performance, scale, or complexity that they can't solve by just grabbing a new framework or a different tool. The problem won't be in the tool, it will be in the foundation, and they won't have the vocabulary or the mental models to understand it. So when we ask if a computing degree is obsolete, what we are really asking is this: is the architect obsolete? Is a deep, foundational understanding of how computation works no longer valuable in America? And the answer is an emphatic no. In fact, you could argue it's becoming more valuable than ever. As the easy problems get solved by better and better tools, and as AI begins to automate the more repetitive builder tasks, the uniquely human value shifts toward solving the harder, more abstract, more architectural problems. The degree, then, is not a ticket to a job. It's an incubation period for a specific kind of problem-solving mind. It's a 4-year bet that the future will require more architects, not fewer. The bootcamp, on the other hand, is a bet on speed and relevance. It's a bet that the immediate demand for builders is so high that a focused, practical education is the most efficient path to a great career. And for hundreds of thousands of people, that bet has paid off spectacularly. So the choice isn't between good and bad. It's between two different starting points, two different philosophies. One starts with a broad, deep foundation and builds practical skills on top of it over time. The other starts with a sharp, practical spearhead of skills and broadens its base of knowledge over time. This brings the whole question into much sharper focus. It's not about the paper. It's about the person you want to become. Do you get more energy from understanding the deep magic behind the technology, or from using that magic to create something tangible right now? Your answer to that question is far more important than any salary chart or list of job prospects. But let's be honest, the practical side of this matters a lot. We've talked philosophy, now let's talk reality. How does this architect versus builder dynamic actually play out in the American job market? What do hiring managers really think? What does the salary data actually say? And what do the long-term career paths for each group look like? Because when we dig into the numbers, the story they tell is far more nuanced and frankly more interesting than the shouting match you see online. So let's talk about the one thing everyone really wants to know: the money. Who actually makes more? The 4-year computer science graduate, or the scrappy self-taught coder who blasted through a 3-month boot camp? The answer, right out of the gate, is almost always the degree holder. And the gap isn't trivial. But this is where the story gets complicated, because starting salary is only chapter 1 of a much longer book. Let's look at the bootcamp promise first. 4 years, the marketing has been incredibly effective. Learn to code in 12 weeks and land a 6-figure job. And for a while, during the tech gold rush of the 2010s, that wasn't entirely a fantasy, especially if you lived in San Francisco or New York. But today, the landscape has shifted. According to Course Report, a major bootcamp review site, the median starting salary for a bootcamp grad in the US is around $80,000. Now, that is fantastic money, life-changing money for many people. But it's not the $150,000 dream often sold in advertisements. In lower cost of living areas, that starting figure can easily dip into the $60,000 or $70,000 range. Now let's turn to the computer science graduate. A 2023 report from the National Association of Colleges and Employers found that the average starting salary for a computer science major was just over $86,000. But that average is misleading. It lumps in graduates from every university, from top-tier schools like MIT and Stanford to small regional colleges. If you look at graduates from the top 50 computer science programs, the numbers explode. It's not uncommon for these graduates to receive starting offers of $120,000, $150,000, or even more, especially when you factor in signing bonuses and stock options from major tech companies. These companies, the Googles, the Metas, the Apples of the world, recruit almost exclusively from these top university programs for their entry-level roles. They set up shop right on campus. For them, a degree from a reputable institution is a filter. a signal that a candidate has already passed a rigorous 4-year-long test of their intellectual and technical abilities. So, on day 1, the CS grad often has a significant salary advantage. Case closed, right? The degree is worth it. Well, not so fast. We've completely ignored the elephant in the room, the colossal cost in both time and money of that degree. Let's create 2 hypothetical people. We'll call them Alex and Ben. Alex decides to go the traditional route. He gets into a good, but not elite, state university's computer science program. Over 4 years between tuition, housing, and fees, he accumulates $80,000 in student loan debt. He graduates at 22 years old, lands a great job, and starts with a salary of $90,000. Ben, on the other hand, decides college isn't for him. At 18, right after high school, he works a minimum wage job for a year to save up. At 19, he enrolls in a well-regarded coding bootcamp that costs $20,000. He works tirelessly for 4 months and after a tough 3-month job search, lands his first junior developer role at age 20, making $70,000 a year. Now let's fast forward to the day Alex graduates. He's 22 years old, $80,000 in debt, and is just starting his first job at $90,000. Where's Ben? Ben is also 22. He's already been working for 2 full years. In his first year, he made $70,000. In his second, he got a small raise to $75,000. So by the time Alex is just starting, Ben has already earned $145,000. He's paid off his $20,000 bootcamp loan and has over $100,000 in the bank or invested. So at age 22, who is financially ahead? It's not even a contest. Alex has a net worth of negative $80,000. Ben has a positive net worth of over $100,000. That's a nearly $200,000 financial swing in Ben's favor. From this perspective, the college degree looks like a catastrophic financial decision. Ben is years ahead in real-world experience, has no debt, and is already contributing to his retirement accounts. He's winning. And for the first 3 to 5 years of their careers, this trend continues. Ben keeps getting experience, hopping jobs every couple of years for a nice pay bump. Alex is working hard too, and his higher starting salary helps him make aggressive payments on his student loans. But he's still playing catch-up. The financial head start Ben got is just too massive. It seems like the self-taught path is the undisputed champion of financial efficiency. But then, something starts to happen around year 5 or 6. A subtle shift that changes the entire trajectory of their careers. The company they both work for now, let's imagine they ended up at the same mid-sized tech firm, announces a new major project. It involves building a complex, scalable system from the ground up. They need a tech lead, someone who can design the core architecture, anticipate bottlenecks, and make high-level decisions that will affect the company for the next decade. Both Alex and Ben are considered. They're both talented developers. They both write clean, effective code. But who gets the job? Almost every time it's Alex. And the reason why has nothing to do with a piece of paper he got from his university. It has everything to do with what that piece of paper represents. You see, a computer science degree at its core is not about learning to code. That's a common misconception. Learning to write Python or JavaScript is a byproduct of the degree, not its purpose. The true purpose of a CS degree is to teach you the fundamental, timeless principles of computation. It's about learning data structures and algorithms, understanding not just how to sort a list, but understanding the difference between a bubble sort and a quick sort, and knowing when one is catastrophically inefficient compared to the other. It's about learning computational complexity, or big O notation, which is the language used to describe how an algorithm's performance scales as the amount of data grows. It's about computer architecture, operating systems, and database theory, the deep foundational knowledge of how the machine actually works, from the silicon chip all the way up to the web browser. Bootcamps, by design, skip almost all of this. They are trade schools, and they are brilliant at what they do, teaching you a specific trade. They teach you how to be a web developer, using the most popular tools of today like React or Node.js. They give you just enough knowledge to be productive on a team and get that first job. It's like teaching someone how to be a phenomenal carpenter who can build a beautiful kitchen. They know which wood to use, how to cut it, how to join it, how to finish it. But a computer science degree is like studying to be an architect. The architect doesn't just know how to build the kitchen. They understand the physics of the entire building. They understand the load-bearing walls, the electrical grid, the plumbing systems, the soil composition beneath the foundation. They can design a 50-story skyscraper because they understand the underlying principles of physics and engineering that govern the structure's stability. So when that big, complex project comes along, the company isn't looking for a carpenter. They're looking for an architect. They need someone who understands not just how to write the code for a single feature, but how to design the entire system to handle millions of users. They need someone who understands the trade-offs between different database technologies, who can design an algorithm that won't crumble under heavy load, who can think about the system as a whole. This is the domain of computer science fundamentals. Ben, the bootcamp grad, is a fantastic developer. But his knowledge is a mile wide and an inch deep. He can build features faster than almost anyone. But when asked to design the system architecture, he's out of his depth. Alex, on the other hand, spent 4 years studying these exact principles. He might not have known the hottest JavaScript framework on day one, but he can learn a new framework in a few weeks. What's much harder to learn on the fly is the deep theoretical foundation of computer science. And this is where the career paths begin to diverge, and where the salary gap not only reappears but widens into a chasm. Let's call them the implementers and the architects. This isn't a value judgment. Both are critical. Society needs people who can build the house from a blueprint, and it needs people who can design the skyscraper. The implementer, often self-taught or a bootcamp grad, excels at taking a well-defined problem and using a specific set of tools, a popular framework like React or a language like Python, to build a solution. They are incredibly valuable, and for the first few years of their career, they might even seem to have an edge. Imagine two programmers starting their careers on the same day. We'll call them Chris and Sarah. Chris went to a top-tier coding bootcamp. He spent 12 intense weeks mastering the MERN stack, MongoDB, Express, React, and Node.js. He's a machine. He can build a full-stack web application, connect it to a database, and deploy it to the cloud, all before his morning coffee gets cold. He lands a job as a front-end developer at a trendy tech startup for $95,000 a year. He feels like he's on top of the world. Sarah, on the other hand, just graduated with a 4-year computer science degree. Her first job is as a junior software engineer at a large, slightly boring enterprise company. Her starting salary is $85,000. In her first year, she's not building cool, flashy user interfaces. She's writing unit tests. She's debugging a legacy system written in a language she barely touched in school. She's spending weeks trying to understand a single, monstrously complex algorithm that handles transaction processing. To an outsider, and maybe even to Sarah herself, it looks like Chris made the smarter choice. He's earning more, his work is more visible, and he's using the latest and greatest tech. Now let's fast forward 5 years. Chris is still a developer at that same startup, which has grown a bit. He's now a senior front-end developer, and his salary has increased to $130,000. But he's starting to feel a sense of unease. The MERN stack, once the pinnacle of web development, is now just one of many options. New frameworks have emerged. The company is talking about a massive architectural shift. They want to move to a microservices architecture, incorporate machine learning for personalization, and build a system that can handle 10 times the traffic. During the planning meetings, the conversation is all about things Chris has only vaguely heard of. They're discussing container orchestration with Kubernetes, the trade-offs between REST APIs and gRPC, choosing the right type of database, relational versus NoSQL, for different services, and the complexities of distributed systems like the CAP theorem. Chris is quiet in these meetings. He knows how to build a component in React. He doesn't know how to design a system that can reliably serve millions of users without collapsing. He's an expert at using the tools, but he doesn't understand the fundamental principles that would allow him to choose or even design the right tools for a new, complex problem. He's a master of the how, but he's lost when the question becomes why or what if. His career has hit a plateau. To advance, he realizes he has to go back and learn the very things he skipped. Now let's check in on Sarah. After 5 years, she's no longer at that boring enterprise company. Her deep understanding of fundamentals made her a prime candidate for a role at a FANG company, one of the tech giants. Her title is now L5 software engineer, which is a senior, high-impact role. Her total compensation, including stock, is over $350,000 a year. The chasm has opened. What happened? While Chris was mastering one specific framework, Sarah was mastering timeless principles. That boring legacy system she worked on, it taught her how large-scale software is actually maintained over decades. Those complex algorithms, they trained her to think about efficiency and scale in a way that goes far beyond just making a web page load quickly. She learned about Big O notation, not as an abstract academic concept but as a practical tool. Let me give you a concrete example of what that means. At her new company, a critical service was slowing down as more users signed up. The team's initial plan, led by some very smart implementers, was to throw more money at the problem, spin up more powerful servers. It was a linear solution. Sarah took a look. She analyzed the code and the database queries and realized a core process was running in O(n squared) time or quadratic time. In simple terms, if the number of users doubled, the processing time didn't double, it quadrupled. If it grew by 10 times, the processing time exploded by 100 times. It was an invisible time bomb ticking at the heart of their system. Sarah, drawing on her deep knowledge of data structures and algorithms from her degree, redesigned the process. She introduced a more sophisticated data structure, a hash map, to change the lookup time from O(n) to O(1), from proportional to the number of users to instantaneous. The overall process went from a catastrophic O(n squared) to a highly efficient O(n log n). The result? The service became 1,000 times faster. The need for new servers vanished. She single-handedly saved the company millions of dollars in infrastructure costs per year. This is the hidden value of a computer science degree. It's not about learning to code. It's about learning to solve problems at a fundamental level. Chris can build you a car. Sarah can design you a new type of engine that's twice as efficient and half the cost. Chris can follow the recipe. Sarah understands the food chemistry so well she can invent entirely new cuisines. The work Sarah does is simply inaccessible to someone without that foundational knowledge. She can reason about distributed systems, design APIs for massive scale, understand the intricate trade-offs of different database technologies, and optimize code at a level that creates astronomical value for the company. Consequently, the company is willing to pay her an astronomical salary. Chris isn't a bad developer. He's a great developer. But he's stuck in a cycle of learning the next framework. He has to constantly reskill on the surface level just to stay relevant. Sarah, on the other hand, invested in skills that are timeless. The principles of efficient algorithms, data structures, operating systems, and computer networks don't change. They are the physics of the digital world. While frameworks come and go like fashion, the laws of computational physics are eternal. This is why, when you look at the highest echelons of software engineering, the staff engineers, the principal engineers, the distinguished engineers and fellows at companies like Google, Microsoft, and Amazon, the ones architecting the future of technology, you'll find they are almost exclusively people with a deep, formal understanding of computer science. It's not about gatekeeping. It's about a simple reality. The problems they are paid to solve are so complex, so abstract, and so consequential that they cannot be solved with the toolkit from a 12-week bootcamp alone. This is the divergence. It's not about a piece of paper. It's about the fundamentally different set of tools you're equipped with to solve problems, and the ceiling that each toolkit imposes on your career and your earning potential. But what about the exceptions? What about the brilliant self-taught hackers who rise to the top? They are real, but how they do it is the most misunderstood part of this entire debate. Let's talk about that mythic figure, the one who fuels this entire debate. The self-taught coder, the bedroom hacker who lands a job at Google with nothing but a GitHub profile and a dream. They are the poster child for the degree is obsolete movement. And they absolutely exist. But their stories are the equivalent of a lottery winner telling you to quit your job and buy scratch-offs. The reason they are famous is precisely because they are so rare. Their success is a story of survivorship bias, and ignoring the thousands who tried and failed is the most dangerous mistake you can make. To understand why this path is so treacherous, we need to dissect the different types of people who actually succeed without a degree. They almost always fall into one of a few categories, and none of them are about just working hard. First, you have the natural, the prodigy. This is the person who wasn't just learning to code, they were born to do it. They were taking apart the family computer at age 9, writing their first video game at 12, and contributing to open source projects before they could legally drive. For them, computer science isn't a subject, it's their native language. They breathe in logic and exhale clean, efficient code. When a company hires this person, they aren't hiring a bootcamp grad. They're hiring a rare talent who would have excelled with or without a formal education. The university wasn't a necessary step for them because they had already internalized the deepest principles of the craft through thousands of hours of obsessive, self-directed practice. Their success doesn't prove the path is viable for the average person. It proves that outliers exist in every field. Trying to replicate their journey is like watching Michael Jordan and thinking you can make it to the NBA by just playing more basketball in your driveway. You're missing the unteachable innate genius that makes them who they are. Next, we have the pivot. This is the most common and most misleading archetype. This is the person who posts on Twitter, "I taught myself to code in 6 months and landed a 6-figure job. You can too." What they conveniently leave out is that they already have a master's degree in electrical engineering, or a PhD in physics, or spent a decade as a quantitative analyst. They aren't starting from scratch. They are starting from a place of immense intellectual privilege. They already possess a deep, rigorous understanding of mathematics, logic, and complex systems. For them, learning Python isn't like learning a new skill. It's like learning a new dialect. They already understand the grammar of problem solving. They just need to learn the new vocabulary. Think of it this way. If you're a fluent Spanish speaker, learning Italian is relatively straightforward. The structure, the roots, the concepts are all familiar. But if you only speak English, learning Japanese is a monumental undertaking. The pivot is the Spanish speaker learning Italian. The person coming from a non-technical background is the English speaker trying to learn Japanese. The advice from the first person is almost useless to the second. They are playing completely different games. These career switchers already have the thinking part down. A bootcamp just gives them the doing part, the specific tools and syntax. That's a huge, often invisible head start. Third is an archetype we don't like to talk about: the connected. This is the person who gets their foot in the door not because their resume was so brilliant, but because their uncle is a VP of engineering, or their college roommate startup just got funded. They bypass the entire impersonal, automated system of online applications and algorithmic resume scanners that reject 99% of non-traditional candidates. They get a warm introduction. They get an interview because someone a hiring manager trusts has vouched for them. This isn't to say they aren't talented, or that they don't deserve the job. They still have to pass the technical interview. But they were given a chance, a precious, invaluable at-bat, that thousands of equally or more talented self-taught developers will never get. Their story isn't one of pure meritocracy. It's one of social capital. Access is often more important than ability in the early stages of a career, and a pre-existing network is one of the most powerful and unreplicable advantages someone can have. Finally, you have the niche dominator. This is perhaps the most strategic and clever of the self-taught successes. This person didn't try to compete with tens of thousands of computer science graduates for generic web developer or software engineer roles. That's a losing battle. Instead, they found a small, underserved, and often unglamorous corner of the tech world and became the absolute best at it. Maybe they became the world's foremost expert on a specific type of software used in geological surveying. Or they mastered the programming language for industrial robotic arms in manufacturing plants. Or they became the go-to developer for a complex, outdated but mission-critical financial software that no one else wants to touch. In these niche worlds, a formal degree is irrelevant. The company doesn't need a well-rounded computer scientist. They need the one person on Earth who can solve their very specific, very expensive problem. This person's expertise is so rare that it completely eclipses their lack of a traditional credential. They didn't win by playing the same game as everyone else. They found a different game to play, one with far fewer players and rules they could help define. This is a brilliant strategy, but it requires incredible foresight, business acumen, and a bit of luck to find that perfect, profitable niche. So, when you look at these archetypes, the prodigy, the pivot, the connected, and the niche dominator, you see a pattern. None of them are simply average person works hard and succeeds. They all possess a significant, pre-existing advantage, whether it's innate talent, a prior technical education, a powerful network, or a brilliant strategic position. The dangerous myth of the self-taught path is that it presents these exceptional outcomes as the norm. It creates a false narrative that the primary obstacle is a lack of effort or the right online course. The reality is that for every one of these success stories, there are thousands of people who followed the same advice, bought the same courses, and coded for the same number of hours, only to find themselves stuck. They are stuck in a cycle of tutorial hell, with a portfolio of generic projects that look like everyone else's, facing an automated wall of resume rejections. They are the silent majority of the self-taught world, and we never hear their stories because failure doesn't get a lot of clicks on YouTube. The successful self-taught developer had to become their own university. They had to be their own demanding professor, designing a curriculum of progressively harder projects. They had to be their own guidance counselor, figuring out what skills were valuable and which were dead ends. They had to be their own networking coordinator, forcing themselves to go to meetups and contribute to open source to build connections. They did all of this without a clear roadmap, without a support structure, And without the final validating stamp of a diploma, it is an act of immense discipline, intellectual rigor, and psychological fortitude. It's not just a cheaper path. It is, in almost every way that matters, a much, much harder one. So the question we have to ask is not, can someone succeed without a degree? We know the answer is yes. The real question is, what is the degree actually providing that makes it the default, reliable path for the overwhelming majority of people entering the field? Because for that $100,000 price tag, you're buying a lot more than just lectures and textbooks. You're buying a system, a structure, and a set of hidden advantages that are incredibly difficult to replicate on your own. Let's call it the unspoken curriculum. It's the set of benefits that are never listed in the course catalog, but are arguably more valuable than the diploma itself. And the first, most important part of this curriculum is something I call the great forcing function. Think about the self-taught path for a moment. It's a path of freedom. You learn what you want when you want. You get excited about building a cool web app, so you dive headfirst into JavaScript frameworks like React or Vue. You see a tutorial on machine learning, so you spend a weekend playing with TensorFlow. It's exciting, it's project-based, and it gives you tangible results you can see and show off. But there's a hidden danger in this freedom. You almost always gravitate towards what is fun, what is popular, and what gives you that immediate dopamine hit of seeing something work. What you almost never do voluntarily is spend a month grinding through the brutal, abstract, and seemingly useless theory of compiler design. You don't wake up on a Saturday morning excited to learn about Carnot maps, finite automata, or the mathematical proofs behind sorting algorithms. You don't choose to study the intricate details of memory management, cache coherence protocols, or the low-level architecture of a CPU. Why would you? It's hard. It's not glamorous. You can't post your new understanding of Big O notation on your portfolio. And yet this is the bedrock. This is the foundation upon which all of modern computing is built. A university computer science program is a 4-year-long forcing function. It's an intellectual boot camp that straps you to a chair and forces you to eat your vegetables. It makes you wrestle with the hard stuff, the theoretical stuff, the stuff that doesn't have an immediate payoff but pays massive dividends in the long run. A self-taught developer who only knows React is like a mechanic who only knows how to change tires. They're useful for sure. But the computer science graduate? They're the engineer who understands the physics of combustion, the principles of thermodynamics, the material science of the engine block. When a truly novel, complex, and system-level problem arises, who do you think is better equipped to solve it? The person who followed a tutorial, or the person who understands the first principles? This forced foundational knowledge is what separates a coder from a computer scientist. It's the difference between being able to use a tool and being able to build the tool yourself. It gives you a mental model of the entire stack, from the silicon all the way up to the user interface. And that holistic understanding is a superpower that becomes more valuable the further you advance in your career. But even that pales in comparison to the second part of the unspoken curriculum, the network. And I'm not just talking about adding connections on LinkedIn. I'm talking about a multi-layered, deeply embedded human ecosystem that is almost impossible to access from the outside. Starts with your peers. Imagine this. It's 2 a.m. in the university computer lab. The air is thick with the smell of stale coffee and quiet desperation. You and 3 other students are huddled around a whiteboard, trying to debug a memory leak in your operating systems project that's due in 6 hours. You've been at it for the better part of a day. You argue, you brainstorm, you test, you fail. And then, finally, one of you has a breakthrough. The code compiles. It runs. The relief is euphoric. That shared struggle, that trial by fire, forges a bond that is incredibly powerful. The people in that lab with you aren't just classmates. They become your professional bedrock. 10 years from now, one of them will be a senior engineer at Google who can refer you for your dream job. Another will be launching a startup and will call you first to be their co-founder. A third will be a hiring manager at a company you want to work for, and your resume will go straight to the top of the pile. This isn't just networking. It's building a trusted inner circle through shared, intense experience. Then there's the next layer, your professors. In the self-taught world, your teachers are anonymous faces on YouTube or Udemy. In a university, they are world-class experts with office hours. They are leading researchers in artificial intelligence, cryptography, and distributed systems. And you have direct access to them. You can go to them with a complex question and have a one-on-one conversation. You can stand out in their class and be invited to work in their research lab, potentially getting your name on a published academic paper before you even graduate. A glowing letter of recommendation from a respected professor can open doors that a portfolio of personal projects never could. They become your mentors, your champions, and your first major connection to the professional and academic world. And finally, there's the top layer, the one that people almost never talk about, the alumni network. This is the secret handshake. When you graduate from a reputable university, you are given a key to a club that has tens of thousands, sometimes hundreds of thousands of members all over the world. These are people who walk the same hallways, struggled with the same professors, and feel a sense of kinship with you, even if they've never met you. When an alumnus who is a VP of engineering at a Fortune 500 company sees your university on your resume, it triggers an instant sense of recognition and familiarity. It's a signal. Says you went through the same rigorous filter they did. It's why an email with the subject line "Fellow Penn State alum seeking advice" gets opened and answered, while a cold email gets deleted. This network is a powerful, invisible current that can pull you through your entire career, offering opportunities, advice, and connections that are simply off-limits to those on the outside. Which brings us to the third and final piece of the unspoken curriculum: the signal. For all the talk about skills-based hiring, the reality is that the American job market still runs on signals. Companies are inundated with thousands of applications for every open role. They don't have time to meticulously review every portfolio. They need shortcuts. They need filters to sort the probable from the improbable. A Bachelor of Science in Computer Science from a known university is one of the most powerful signals you can send to an employer. It doesn't just say, "I know how to code." It says, "I was able to get into a competitive program. I was able to commit to a difficult 4-year goal without quitting. I was able to navigate a complex bureaucracy, meet deadlines under pressure, and collaborate with others on long-term projects. I have been vetted." It de-risks you as a candidate. The burden of proof is immediately lower. For the self-taught developer, the burden of proof is immense. You have to build a portfolio so stunning, a GitHub profile so active, and a personal brand so compelling that it screams, "I am the exception. I am worth the risk." It's absolutely possible, but it's an uphill battle fought on a field designed by and for the traditionally educated. The degree is a credential. It's a stamp of approval that gets you past the automated resume screeners and into the hands of a human being. Gets you the interview. After that, your skills have to do the talking, but the degree's primary job is to get you in the room where it happens. So the university provides the forcing function for deep knowledge, an unparalleled multi-layered network, and a powerful signal that opens doors. It sounds like an open and shut case, right? A clear victory for the traditional path. But this is where our story takes a sharp turn, because that very same system, that structured, legacy-filled institution, is now facing a crisis. It's being attacked not just from the outside by bootcamps and online courses, but from the inside out by the very industry it was designed to serve. And this internal attack is, in many ways, far more devastating than any bootcamp. It's a quiet revolution happening in the HR departments and on the job description pages of the most powerful companies on Earth. It's the rise of a simple, yet world-changing philosophy: skills over degrees. For decades, the bachelor's degree was the golden ticket, the non-negotiable price of entry into the professional world. It was a proxy for intelligence, for diligence, for competence. But then, the very companies that computer science graduates were flocking to started to poke holes in that assumption. First it was a whisper, then it became a public statement. Google, Apple, IBM, Tesla. One by one, these titans of tech began to publicly announce that a college degree was no longer a firm requirement for many of their roles. Elon Musk famously said that a degree is not evidence of exceptional ability, stating he'd rather see a super compelling record of achievement. Former IBM CEO Ginny Rometty went even further, revealing that up to a third of her company's new hires in the US didn't have a traditional 4-year degree. She called for a new era of new-collar jobs, where relevant skills, not academic pedigree, were the currency. This wasn't a PR stunt. It was a calculated business decision born out of a stark reality. The tech giants realized they were artificially shrinking their own talent pool. They were filtering out brilliant, self-taught programmers, savvy systems administrators, and creative designers who, for a million different reasons, cost, family obligations, or simply a different way of learning, hadn't taken the university path. They saw that the pace of technological change was so rapid that a curriculum set in stone 4 years prior was often teaching obsolete frameworks by graduation day. A university could teach you the theory of machine learning, But the self-taught coder who had spent the last 6 months building projects with the latest TensorFlow library was often more immediately valuable. The industry needed doers, builders, and problem solvers. And they found that a pristine GitHub profile, a history of contributions to open-source projects, or a portfolio of stunningly complex personal projects was often a far better predictor of on-the-job success than a 3.2 GPA in theoretical computer science. The interview process itself became the great equalizer. The dreaded technical interview, the whiteboarding session, the take-home coding challenge, these became the true gatekeepers. No one in a Google interview asks you what grade you got in your operating systems class. They ask you to invert a binary tree on a whiteboard right now. They don't care if you learned it in a lecture hall at Stanford or from a YouTube video in your basement. They only care if you can do it. And then the industry took its revolution a step further. It wasn't content to just ignore the old credential. It decided to create its own. The perfect case study is the Google Career Certificate. Think about what this is. Google, one of the most desirable employers in the world, created its own low-cost online training programs for high-growth fields like IT support, data analytics, and UX design. They designed the curriculum, they taught the skills, and they issued the certificate. But here's the killer blow. Google then announced that they, and a consortium of over 150 other major US companies including Walmart, T-Mobile, and Deloitte, would consider these certificates as the equivalent of a 4-year degree for related roles. Let that sink in. The industry itself created a direct, 6-month, low-cost alternative to a 4-year, $250,000 degree, and then validated it with a promise of employment. This is not a subtle critique of the university system. This is a declaration of independence. It's a statement that says, we believe the traditional model is too slow, too expensive, and too disconnected from the skills we actually need. So we're building our own pipeline. This fundamentally changes the equation for a prospective student. The value of a degree has always been tied to its exclusivity as a signal to employers. But when the employers themselves start creating and accepting other signals, the value of that original signal inevitably drops. The piece of paper is no longer the only game in town. It's being devalued in real time by the very market it's supposed to serve. Now, this is the point where we have to be incredibly careful. It is easy and frankly lazy to hear all of this and declare the computer science degree dead. That is not the surprising truth. The truth is far more nuanced and, for anyone trying to make a decision, far more complex. Because while the degree is no longer the only key, it is, for many, still the master key. For a young person straight out of high school with no professional experience, a degree from a reputable university is still the most powerful signal they can send to the world. It signals that you can commit to a difficult long-term goal. It signals that you can withstand academic rigor. It signals that you can learn complex, abstract concepts and see them through to completion. A bootcamp certificate signals you can do a specific task. A CS degree signals you have the potential to do any task. And let's talk about the single most underrated asset of a university: the foundation. A great CS program doesn't just teach you how to code in the language of the day. It teaches you the eternal, underlying principles of computation. It teaches you data structures and algorithms, the grammar of problem solving. It teaches you computational complexity, so you understand why one solution is a million times faster than another. It teaches you computer architecture and operating systems, so you understand what's actually happening down at the level of the silicon when you run your code. A bootcamp might teach you how to build a house using a modern nail gun. A university teaches you the physics of structural engineering. The bootcamp graduate can build a house for sure. But the university graduate can invent a new kind of nail gun or design a skyscraper. These fundamentals are timeless. They are the intellectual toolkit that allows a software engineer to adapt and thrive over a 40-year career, long after JavaScript frameworks like React and Angular have been replaced by something new. This deep theoretical underpinning is something that self-study and bootcamps, for all their strengths in practical application, often struggle to replicate. So the crisis for universities isn't that their product has become useless. The crisis is that their monopoly on credentialing high-level technical talent has been shattered. For a century, they were the sole gatekeepers. Now the gates are wide open with multiple paths leading to the same destination. This new competition is forcing them to confront a terrifying question they've never had to answer before. In a world of cheaper, faster alternatives, is a 4-year computer science degree still worth the astronomical price tag? The very definition of what it means to be qualified for a career in technology is being dismantled and rebuilt before our very eyes. And for anyone standing at a crossroads, a high school senior, a mid-career professional looking for a change, navigating this new landscape is treacherous. The old map, the one that said go to college, get a degree, get a job, is becoming faded and unreliable. But if the old map is wrong, how in the world do you find the new one? The new map isn't a map at all. That's the secret. The old way was a static piece of paper with a dotted line leading from point A, high school, to point B, secure job. It was predictable, it was comfortable, and it's gone. The new way isn't a map. It's a compass and a toolkit. It doesn't tell you where to go. It teaches you how to navigate any terrain, no matter how the landscape shifts beneath your feet. And the first tool you need to master is a radical shift in identity. You must stop thinking of yourself as a student trying to get a degree or a graduate trying to get a job. You must start thinking of yourself as a professional problem solver who uses technology as their primary tool. That's it. That's the entire game. A company doesn't hire a computer science BS. They hire someone to solve a problem they have. The degree was once the best signal that you might be able to solve their problems, but now there are far better signals. The first principle of this new navigation is becoming what industry insiders call a T-shaped individual. Imagine the letter T. The horizontal bar at the top represents the breadth of your knowledge. This is your general understanding of many different areas. A little bit about databases, a little about front-end, a little about networking, a little about project management. This is what a good university program is actually great at providing, that broad foundational context. It gives you a language to speak with different specialists. But in today's world, that's just the ticket to entry. It's not enough to get you hired. The real value, the thing that gets you noticed in a sea of applicants, is the vertical bar of the T. This is your deep, undeniable expertise in one specific area. Not just, I know Python, but I am an expert in using Python for natural language processing to analyze customer sentiment data. Not, I know JavaScript, but I specialize in building highly performant, accessible user interfaces using React and Next.js for e-commerce platforms. This is your spike of excellence. It's what makes you the go-to person for a specific high-value problem. The old model of education created thousands of people with the same horizontal bar. The new model requires you to dig your own vertical well. You have to choose your specialty and go deeper than anyone else. You have to become obsessed. This is where the degree falls short, because it can't, by design, make you a world-class expert in a niche. That part is on you. The second, and arguably most important principle is this: your portfolio is the new resume. Let me say that again. Your portfolio is the new resume. A resume is a claim. It's a piece of paper where you say, I have skills in Java and SQL. A portfolio is proof. It's a collection of living, breathing projects where you show, here is the full-stack application I built using Java and SQL to manage inventory for a hypothetical small business. You can click here to use it right now. And here is the link to the clean, well-documented code on my GitHub. Now imagine you're a hiring manager. You have two candidates. Candidate A has a 3.9 GPA from a great school. Their resume lists all the right keywords, but their GitHub is a ghost town. Candidate B has a 3.2 GPA from a state school, but their GitHub is a treasure trove. They've built a web scraper that tracks pricing data on a popular retail site. They've contributed to an open source library. They built a mobile app for fun that helps people identify local plants, and it has a few dozen users. Who are you going to call? It's not even a question. You're going to call Candidate B every single time. Why? Because Candidate A is a risk. Their skills are theoretical. Candidate B is a known quantity. They have demonstrated not just technical skill, but also passion, initiative, and the ability to ship a finished product. The degree gets your resume past a basic HR filter. Your portfolio gets you the interview. And when you build your portfolio, don't build another to-do list app or a simple calculator. Solve a problem. Find a pain point in your own life, or the life of a friend, and build something to fix it. Document your process. Write about the challenges you faced and how you overcame them. That's not just a project, that's a story. And stories are what get you hired. This leads directly to the third principle of the new map. You must treat learning as a lifestyle, not a phase. The university model creates a dangerous mindset that learning is a 4-year process with a finish line called graduation. In technology, that mindset is a career death sentence. The skills that are in high demand today might be commoditized or automated in 5 years. The programming language everyone is excited about right now could be a legacy system in a decade. The only sustainable advantage you have is your ability to learn, adapt, and evolve faster than the pace of change. This means you are never done learning. You have to build a personal system for continuous improvement. This could be dedicating 5 hours every week, no matter what, to learning a new technology. It could be reading the source code of a library you use just to understand how it works. It's contributing to open source projects. It's following and engaging with smart people in your field on social media. It's building small, experimental projects on the weekend just for the joy of it. The degree gives you the ability to learn how to learn in a structured way. Your career depends on you taking that ability and applying it relentlessly for the next 40 years. The game isn't about what you know right now. It's about how quickly you can learn the next thing. Finally, the fourth and most overlooked principle: mastering the skills that everyone calls soft, but are in fact the hardest and most valuable. I'm talking about communication, collaboration, and business acumen. Let's call them leverage skills, because they take your technical ability and multiply its impact. You can be the most brilliant coder in the world, a 10x engineer, but if you can't clearly explain a complex technical concept to a non-technical manager, your brilliance is trapped. If you can't work effectively with a team, write clear documentation, or accept constructive feedback, you become a bottleneck. Your value plummets. In the modern tech world, you don't build things in a vacuum. You build them with product managers, designers, marketers, and other engineers. Your ability to communicate your ideas, to understand the business goals behind a technical feature, and to be a positive force on your team is what separates a good engineer from a great one. And here's the secret. You develop these skills the same way you develop coding skills, through practice. Every time you write a README for a project, you are practicing written communication. Every time you collaborate on a group project, you are practicing teamwork. Every time you explain what you're working on to a friend who isn't in tech, you are practicing your ability to distill complexity. The degree doesn't guarantee these skills. In fact, the competitive, individualistic nature of some university programs can actively work against them. Building these leverage skills is entirely up to you, and it's what will ultimately define the ceiling of your career. These four principles: the T-shaped expertise, the portfolio of proof, continuous learning, and leverage skills. This is the new compass. It doesn't give you a simple path. It gives you something far more powerful: the ability to forge your own. And that ability, that power to navigate the unknown, is the single most valuable asset you will ever possess in the 21st century. For generations, we were sold a map. The map was simple. Go to a good school, get the right piece of paper, follow the marked road, and you'll arrive at a safe destination called a stable career. We obsessed over having the perfect map. We paid hundreds of thousands of dollars for premium, laminated, GPS-enabled maps. But then an earthquake hit. An earthquake called AI, automation, and globalized talent. And in the blink of an eye, the landscape changed. The roads disappeared. The landmarks moved. The map we paid so much for became a useless, outdated piece of paper. And people are standing around holding their expensive, useless maps, terrified. They're waiting for someone to issue a new one. But the new one is never coming. The game has changed. The world no longer rewards people who can follow a map. It rewards people who can use a compass. It rewards people who can look at a wild, untamed, and constantly shifting landscape and say, I know which way is north. Those four principles: the T-shaped expertise, the portfolio of proof, the habit of continuous learning, and the leverage skills, that's not a map. That is your compass. It doesn't tell you which road to take. It tells you the direction of value. It allows you to forge a path where none exists. So let's finally answer the question that brought you here. Is a computing degree obsolete in America? The surprising truth is this: the degree is not obsolete, but our reason for getting it is. Our entire understanding of its purpose is fundamentally, catastrophically, outdated. We still see it as a golden ticket, a one-time purchase that grants you access to the professional class for the next 40 years. That version of the degree is dead and buried. It's a ghost. Continuing to believe in it is like trying to pay for your groceries with a check from 1985. The cashier will just stare at you with a mixture of pity and confusion. The new role of a computing degree is not that of a golden ticket, but of a foundational accelerator. Think of it like this: you have to build a skyscraper, which is your career. You can absolutely start digging the foundation with a shovel. You can learn everything on your own, piece by piece. It will be brutally hard, it will take a long time, and you might make some critical structural errors along the way. But it is possible. Many brilliant people have done it. A good degree program, however, doesn't build the skyscraper for you. It shows up on day one with a fleet of excavators, a team of surveyors, and a pre-approved set of blueprints for a solid foundation. It accelerates the messy, difficult foundational part. It gives you a structured environment to learn the deep theory, the why behind the code, that self-taught developers often miss. It gives you a network of peers and professors. It gives you a credential that, yes, still opens some doors, especially at large traditional corporations. But here is the critical part. It only builds the foundation. That's it. The excavators leave after 4 years. If you stand around on your pristine concrete slab, holding your degree, waiting for someone to come and build the rest of the skyscraper for you, you will be waiting forever. You will watch as the person with the shovel, the one who has been relentlessly building floor by floor, day by day, creates a towering structure while you're still standing on the ground floor. The degree is a catalyst, not a conclusion. Its value is no longer inherent in the paper itself, but in the velocity it gives you at the start of your journey. And this leads to the other side of the surprising truth. For some people, it is obsolete. If you are a disciplined, obsessive self-starter who can build your compass without the formal structure, if you can dive deep into theory on your own, build a stunning portfolio, network like a master, and communicate with flair, then the $100,000 price tag and 4 years of your life might be a terrible investment. The choice is no longer binary, it's strategic. The degree has been demoted from a prerequisite for success to one of many potential tools you can use to achieve it. So the real question isn't about the degree. The real question is about you. Are you building? Are you creating proof? Are you learning every single day as if your career depends on it? Because it does. The fear you feel about AI, about your job becoming obsolete, is a signal. It's your subconscious telling you that relying on old credentials is no longer a viable strategy. It's time to build a new one. And I don't want you to just feel inspired by this. I want you to take action. Right now. Let's do it together. Let's call it the Career Future-Proofing Challenge. It's a 30-day sprint to start building your compass. Week 1 is the audit. This week, you're not writing a single line of code for a new project. You are a forensic accountant, and your career is the book you're auditing. Be brutally, uncomfortably honest with yourself. First, draw a giant T on a piece of paper. Map your skills. How deep is your vertical stock? Are you truly in the top 25% in your niche? Or are you just pretty good? Now look at the horizontal bar. What's there? Communication, project management, sales, visual design, content creation. Is it empty? Be honest. Second, open up your portfolio or resume. Look at every single project. Ask yourself, does this piece of work scream problem solver? Or does it whisper followed a tutorial? Does it show quantifiable results? Or just a list of technologies? If a hiring manager or a potential client looked at this for 10 seconds, would they be intrigued or bored? Your goal this week isn't to fix anything. It's to generate a completely honest, unfiltered assessment of your starting point. Week 2 is the project of proof. Armed with the insights from your audit, you're going to start one project. Not 10. 1. It must meet 3 criteria. First, it must solve a real problem. Not a generic to-do list app. Find a painful, annoying problem in your own life, or in a community you care about, and build the solution. Second, it must force you to learn something new that pushes you along your T-shape, either deeper in your specialty or wider in a leveraged skill. Third, you must document the entire process. Not just the final code, but the journey. The initial idea, the failed attempts, the bug you spent 3 days on, the breakthrough. You can do this in a blog, a series of tweets, or a simple public Google document. This documentation is more valuable than the code itself because it proves you can think, struggle, and win. Week 3 is the leverage engine. This week, you will dedicate 30 minutes every single day to building leverage. This is not about mindlessly spamming your resume on LinkedIn. This is about giving, not taking. Find 5 people in your field you admire and leave thoughtful, insightful comments on their posts. Not great post, but something that adds to the conversation. Take one small thing you learned in week 2 and turn it into a mini tutorial. A short blog post, a Twitter thread, a 1-minute video. Answer a question on Stack Overflow or Reddit with a clear, helpful, well-written response. You're not asking for a job. You're becoming the kind of person people want to hire. You're building a reputation as someone who is skilled, helpful, and an excellent communicator. You are building your network by proving your value to it. Week 4 is the learning system. The final week is about turning continuous learning from a vague concept into a non-negotiable system. Choose one, and only one new skill you want to develop over the next quarter. It could be a new language, an AI framework, or a public speaking course. Now, open your calendar and block out 5 hours a week to work on it. Treat these blocks like a meeting with the CEO of your career, because that's what they are. This isn't about a vague goal like, I want to learn Python. It's about a system. Every Tuesday and Thursday from 7 a.m. to 8:30 a.m., and every Saturday from 9 a.m. to 11 a.m., I am working through my Python data science course. A goal is a wish. A system is a machine that produces results. That's it. 1 month. It won't make you an expert overnight, but it will fundamentally shift your trajectory. It will move you from being a passive passenger, hoping the old map is still right, to being an active navigator, forging your own path with a compass that actually works. The terror of obsolescence, the fear that AI will take your job, it's real, but it's not a death sentence. It is a wake-up call. It's the world screaming at us that the era of coasting on credentials is over. The future doesn't belong to the person with the most degrees. It belongs to the person who can provide the most value. It belongs to the relentless learner, the creative problem solver, the master communicator. It belongs to the builder. The conversation we've had here doesn't end with this video. It's just the beginning. So down in the comments, I want you to declare it. What is the one single action you are going to take this week to start building your compass? Are you auditing your skills? Starting that project you've been putting off? Let's use that space to connect and hold each other accountable. And if this video helped you see the path forward with more clarity, do me a favor and subscribe. Because we're not just going to be talking about the future of tech and careers here. We're going to be building it together. The question is no longer, is my degree obsolete? The question is, what problem am I going to solve today? Now go solve it.